Welcome back. Here we are for part 2 of Chapter 5, Sections 8 and 9 notes in the Algebra 2 textbook. Here we're given the equation of a function that we need to graph. For example 1, the function is f of x equals 1/4 x plus 1 squared times x minus 4. The book gives us a small graphing grid to use and a set of steps that we're going to do. First step is use the intercepts. And then because -1 and 4 are zeros, those come from the factors. Right? -1 comes from that factor, 4 comes from that factor. Anyway, because -1 and 4 are zeros of f, we plot the points -1, 0, and 4, 0. This is a connection between the factors, the zeros, and the x-intercepts on the graph. This was in the grid from before, on the prior page. Step 2, plot points between and beyond the x-intercepts. What they're saying here is go ahead and fill in some dots around the known x-intercepts. It'll help us make a nice smooth curve. Basically, we just need to do some substitution with some x values, figure out y values so we can put them on the graph. Because the function comes in factored form instead of looking like a polynomial, we cannot use synthetic substitution. We will have to use direct substitution instead. So when you substitute in -2 for x, you get -1.5 for y. When you substitute in 0 for x, you get -1 for y. When you substitute in 1 for x, you get -3 for y. Substituting 2 in for x gives us -4.5 for y. Substituting 3 for x gives us -4 for y. And substituting 5 for x gives us 9 for y. If you look at the grid, we can plot most of these points. We use the point -2, -1.5, 0, -1, 1, -3, 2, -4.5, 3, -4, and then because the grid given to us, 5, 9 is simply not going to happen on this grid. Now the next step, step 3 in the book's plan, is to look at end behavior. It says because f has factors of the form, because f has, here we're looking for 3 factors of the form x minus k and a constant factor of 1/4, it is a cubic function. Because it has 3 factors, it's going to eventually end up as x to the 3rd, and it has a positive leading coefficient. So it says so f of x goes to, this is going to be -infinity as x goes to -infinity, and f of x goes to infinity as x goes to positive infinity. Now, I want to go back to the fact that it says f has 3 factors. If you look at the given function f, it looks like it might only have 2 factors. But that's kind of an illusion because the first one, x plus 1 squared, you know what, excuse me, let me do that in some sort of different color. X plus 1 squared, that is actually 2 factors because of the squared. And then x minus 4 is 1 more factor. So that's why it really has 3 factors. If we look at the end behavior business, we know that it goes to -infinity as x goes to -infinity. That was a terrible arrow. There we go. And it goes to infinity as x goes to positive infinity. So the arrows are something like that. And then we're going to fill it in. And I'll let you in on a little secret that is not outlined in these notes. And that is that business with x plus 1 squared being two factors, that means the graph bounces off that x-intercept. It does not go through the x-intercept. It bounces right off. In fact, it means exactly that it acts like a parabola at -1 because it was x plus 1 squared. And pretty much just kind of connect the dots. In contrast, at 4, it comes from a single factor of x minus 4. It's x minus 4 to the first. So it heads straight through, just like a line. This is how we can use our information about factors and zeros to make x-intercepts. We add in our information about end behavior, and all of a sudden we have ourselves a graph. Thank you.